Let's dive in and have a look at LangChain expression language. To start with, what we're going to look at is something called the Runnable protocol. All of LangChain expression language is built on something called a Runnable protocol syntax, and so by understanding a lot of the primitives behind this, you'll gain a thorough understanding of how you can apply LangChain expression language. So let's have a look inside of this notebook. The first thing that we're going to introduce is something called the Runnable lambda. Now, a runnable lambda is a little bit like a lambda function that you know in Python. So for example, I can make a lambda function and I can do something like this, where the value of x is equal to x plus 1, right? So I could assign this to a word like function, and then I can say function 1 plus 1 would be equal to 2. Now, in LangChain expression language, we can't necessarily use a standardized lambda function inside of Python, to start with at least. So each time we have to start with a LangChain expression language syntax, you'll probably use something like a runnable lambda. So in this scenario, you can see we have our runnable lambda, and inside there, all we're doing is doing the exact same thing that I did above, which is basically runnable lambda x plus 1, right? So we can make a chain out of this. So we can just save that to a variable, and then if we have a look here, you'll see we've got this runnable lambda. Now, because LangChain expression language comes with a lot of different functionality, you get some functions inside of this by default. So for example, you've got .batch, .abatch, .invoke, and you've also got streaming capabilities as well. Now, if we do, for example, .invoke, you'll see that we get back, if we put 1 in, then it goes into our lambda function and it will get 1 plus 1 added to make 2. Or we could do a chain.evoke. You'll notice that we don't have to have runnable lambda on the second expression. You only need a runnable lambda on the first expression before you can start using lambda functions. Also notice that we are using something called the pipe operator. Now, the pipe operator basically states that we're creating a runnable lambda, and then the output of that runnable lambda will get piped into this function, this lambda here. So what ends up happening is when we have this line here, sequence.invoke, that will then do 1 plus 1, and then afterwards we then pipe that in, which is 2, and then we times x here by 2 to get 4. So you'll see if I run this, then you've got 4. And it's also possible to do this with the .batch functionality. So the .batch will do a list of results and it will run it through the runnable sequence. So in this scenario, we've got 1, 2, and 3, which will appropriately get put into this first runnable lambda each at a time. And then also they will get piped out into this second lambda. So then those will become 4, 6, and 8. So the .batch and the .invoke are our general ways of calling these lambdas. There's also something called the runnable parallel. Now, the runnable parallel is slightly different in the sense of it allows you to have something that goes into 2. We've got an example here. We've got sequence, runnable lambda, x plus x is plus 1. And then that goes into 2 dictionary keys. Notice the pipe operator again. So again, we've got this pipe operator, which is saying this is the input into our runnable lambda. The output then goes into a dictionary with 2 keys, mul2 and mul5, and that is going to be a lambda function. So this is runnable lambda, and that will be doing timesing the value by 2 and also timesing the value by 5. So I can do something like this, and I can say take the 1, which then gets added, so that's 2. And then after that, then I will both times 2 by 2 and times 2 by 5 at the same time and put those into separate dictionary keys. Now, there's another way of writing the runnable parallel. So if we just scroll down here and have a look, this is the equivalent of making a runnable parallel. So you can either use a dictionary with the keys, or you can actually define it up front as a runnable parallel. Let's have a look at this example up above, where we have a runnable lambda, which is saying take x and add 1. The output of that should go into 2 dictionary keys, mul2 and mul5. So the output of this will then get times by 2 and times by 5. But you don't just have to stop there. You could finally pipe that dictionary into a new lambda function and take the addition of the mul2 and the mul5 key. And this shows you that we can easily pipe between not only a Lambda function, but also into a Python dictionary, and then back into a Lambda function as well. You'll see the same thing happening here, which is just to demonstrate that a runnable parallel and a parallel to, although they are different in terms of how you construct them, they basically are the same thing, where we have this dictionary and it's doing several things from the previous output, and the same is true of the runnable parallel. We can then set up our parallel like this. So we have the runnable parallel with the two dictionary keys, mul2 and mul5, which will then get piped into a new runnable lambda. Remembering that the dictionary keys are mul2 and mul5, we can then add those keys together and invoke those. This here is basically saying, take in my dictionary, which contains two keys, and you can see what these are would be input 1 and input 2. And so basically what I'm saying is get the keys of this, input 1 and input 2, assign those, and then after those have become mul2 and mul5 by timesing them by 2 and 5, then pipe them into this runnable lambda expression here, and then add those together. So they're slightly different, but very similar. This one is allowing us to index on a dictionary, whilst this one is basically just saying, let's do something twice to the data, and then let's output that on two separate keys, which we then add. Whilst on this example, we're actually saying, let's take a dictionary, and every time we get a dictionary as the input in our .invoke, what we really want to do, get the input 1 key, get the input 2 key, and then make these new dictionary keys, which we then at this point would then do a mul2 plus mul5 addition inside of a runnable lambda. So you can see all the different types of patterns that you can use when it comes to building this. Now, you do need a runnable at the start of a LangChain expression language expression. So for example, if we try and do this, where we have a lambda, which is x plus 1, and we try and pipe that into a runnable parallel, you'll see that when we try to run the .invoke, it will actually fail here. And the reason why is that this lambda doesn't have an invoke method. It's basically just a lambda function. So what you have to do is, at least to start with, you need either a runnable parallel or a runnable lambda, or any kind of runnable that would work. And after that, you can then start to use standard lambda functions inside of Python. So you'll see in this expression, we've got a lambda which has x plus 1, and then piping that into parallel, which we can see here is just a dictionary with two keys, mul2 and mul5, and then timesing it by 2 and 5 respectively. When we call the .invoke, you'll then see that we get back our Python dictionary with both mul2 and mul5. We can also combine several steps into a runnable. So you can see here we've got item 1 and item 2. And then what we're doing here is then on the fly doing a lambda x hello and a lambda x world. What we can then do is we can make a function which takes an x, which will be a dictionary, and we can return item 1 and item 2. So item 1 would be here, item 2 would be here, and we can add those two together. Now we can say take our runnable parallel and pipe that into this combine function. So the output of the runnable parallel, which is a dictionary with two keys, gets piped and becomes x. Once it becomes x, then what we do is we then say, okay, right, that's great. So because we didn't use anything from the previous step, that's why we're just doing x here and for hello and world. So we didn't actually pass any data in. So when I run this code, you'll see that we just get hello world. So what's really happening here is we have a parallel, which is an item 1 and an item 2. It doesn't have any current inputs. I could also have an input here, for example, so I could have the name. So if we were to change this slightly, let's have a go. We could say X, and we could say we want to take in the name, hello, and then we'll put a space. And then now it will complain about a key error, which is missing with name. So I can then fill that in with James. And now you'll see I get hello James world. You can say welcome to the world, something like this. So basically you can use inputs, but the important point that we have here is we are basically saying take this name, use it once in this runnable parallel, and then in the item 2 we're just going to say welcome to the world. When we do the .invoke, that will then get passed to parallel, the input for the name. And then after that, we then combine that together, these two dictionary keys, which is the item 1 and item 2 keys. So you can see how this starts to build up. what I would recommend doing is spending another 5 minutes now before moving on to the next video and just try and create your own chains using a mixture of runnable parallels, and also try and use a mixture of runnable lambdas and Python dictionaries. Try piping some data to forward steps to see how does this work. And then once you feel a bit more comfortable with it, then move on to the next video.